I'm creating, or I have already created, 3 Spring Boot applications. One will act as a config server. The another is a REST API called the book service, which actually has just one endpoint that will expose a list of books. And the last is the API gateway through which we will communicate with the book service. And if you look at the config server, I'm using Gradle as the build tool here with the plugins available from Spring Boot, as well as a plugin called Jib given to us by the Google guys for creating an image of this particular application. I'm using JDK 11 for this application, and you can see there is the Spring Cloud config server as the dependency. And the last thing is the Jib configuration itself that uses the base image, the Amazon Corito 11. And then it will be creating an image with this particular image and the particular tag that will be the project.version, which is 1.0. So I have already built the image. The image will take this particular name and the version, the tag will be 1.0, which I have already done and uploaded to the ECR. So this configuration application is very simple. It points to the Git repository where I have the properties of the other microservices that I have created. And then comes the book service. Again, this book service is pointing to the configuration server from which it will receive the properties of this particular application. Again, this has just one entity called book, and I'm using a faker library. And you can see in the build.gradle file, again, the same plugins are being used, the Zip plugin, which will ultimately create the image, which I have already pushed into the Elastic container repository. And here in this case, I'm not using the web MVC, I'm using a web flux, but that is not our point of discussion. And you can see I'm using the data faker library to create some fake data, which I'm using in this book entity. So in the constructor, I'm giving some fake names. And then when the application boots up, I'm creating some 10 book instances and then saving into the in-memory H2 database. And lastly, I have the book controller. As I told, I'm using the web flux. So we are expecting a list of books because it is web flux. We are expecting a flux of books when we hit the book and the list endpoint. Again, going back to the application.yaml file, it is pointing to the configuration server at this particular location. That's all this book service is all about. And the last microservice is the API gateway. So the API gateway is used as a front end that will communicate with the book service. So I have just one configuration here. It will look for a book service URL hit. If that is the case, we are going to hit the booking service. So this booking service I have injected here. So this is the booking service, which I have created a root properties just as a placeholder. And of course, as I told you, all these microservices will be communicating with the configuration server to get its corresponding properties. So you can see here, I have the AWS discovery config as the repository, where I have these two property files deposited, one for a booking service, which runs on port 8090 with the corresponding H2 database configuration, and the API gateway configuration that works on 8080 port, and it has the gateway.booking service pointing to the book service. And of course, I'm using an environment variable that will be provided when we deploy this application as a Docker container in ECS. That completes our discussion on the minimum or the minimal Spring Boot application. What next? Next is the VPC. So we'll talk about the different VPC that I have created in the next video. And you can see I have created a VPC, a custom VPC with the class C network with a CIDR of 16. I have created 4 subnets. So if I filter for that particular VPC, you can see 4 subnets created, 2 public subnets, one at each availability zones, and then 2 private subnets also deployed into 2 availability zones. And I have created an internet gateway that is attached to the custom VPC. And then I have created the route tables. The one is the route table, which will be or which has been associated with the 2 public subnets and their corresponding routes pointing to the internet gateway. So already I have created a NAT gateway again with the VPC, and I have put this particular NAT gateway in one of the public subnets. And then for the route table, I have created for the private subnet, and you can see this particular route table is associated with the 2 public subnets, and the routes of that particular the routes have been configured to point to the NAT gateway. This is the minimum VPC configuration that I have already provided. That is all there is to it. Apart from this, I have created the Elastic container registry, and I have already committed the images for the config server, the book service, and the API gateway. That's all is the minimal infrastructure that is required for deploying our application into ECS. In the next video, we will talk about how exactly we are going to create the security groups, the load balancer, and the ECS. This video, we are going to do some more basic infrastructure. So in this case, let us go to the EC2. So the first thing that we are going to do is to create some security groups. So the first security group is going to be associated with the internal load balancer, and the second security group is going to be associated with an external load balancer. So first, let's create a security group for the internal load balancer. So I will give internal application load balancer security group. I will copy paste the same in the description. Instead of the default VPC, we will select the custom VPC that we have created. So this particular security group is going to allow any HTTP traffic emanating from the VPC, that is 192.168.0.0/16. So this means that the security group is going to be associated with an internal load balancer. That internal load balancer will allow any traffic coming to the port 80 from inside the VPC, because we had created the VPC with this particular network. That's all there is to it. Let us create the security group. And that's it. So we have created the internal load balancer security group. So let me give a name to this, save it. We are going to create one more security group for the external load balancer. So let us give an external application load balancer security group. Let me copy paste this in the description too. So again, this will be for our custom VPC. And then we are going to have an inbound rule. Again, the same HTTP from, so this it is coming from anywhere. So that means anywhere outside the internet. If they hit the port 80, this external load balancer, which is going to be associated with the external I mean the security group, which is going to be associated with an external load balancer, will allow traffic at port 80. Let us create the security group. So we have effectively created two security groups as we have done previously. Let us just copy and give the name also here. So one internal security group that is going to be associated with an internal load balancer, which will allow port traffic from the VPC, and an external load balancer, which is going to be associated with the external application load balancer, which will allow traffic at port 80 from the internet. Now it is time to create the load balancers itself. So clicking on the load balancer, again still we didn't go anywhere. All these things are available when you go to the EC2. Let us create a load balancer. So there are different types of load balancers. We are going to go with an application load balancer because it works at the HTTP level. And so let us go ahead and create it. So this is going to be, I will give it as application load balancer and give a private as the name. And of course, there are two options. This is going to be internal facing, and then which is the VPC. This should be associated to our custom VPC. Because we are creating an internal load balancer, it has to be associated with the private subnets only. So two availability zones, you can see here, if I just change it to public, Amazon will give us a warning that your internal load balancer must have a private subnet. So we need to have private subnets here. That's what I have selected here. And then the security group is going to be our internal application load balancer security group. Do you remember how do we create this? This will allow traffic at port 80 from the VPC. And then the listener, that means it will listen at port 80 and to which target groups. The target group means the instances that is going to be run in the EC2 instance. But here there is a catch. We are going to create a target group, but it won't be the target group that we'll be using. So what I'm going to give, I will give a dummy private as the target group because it is going to be, and I will leave everything as blank. So I think I have to create, yeah. So the target group, why I'm giving this as dummy, because when we go to the ECS and create the service there, at that time, a target group will be provisioned there. That is the actual target group. But because Amazon doesn't allow us to create a load balancer without a target group, we are forced to create a dummy target group like so. Again, we won't be using this target group. We will delete it later, but we are doing it anyway. So because we are not going to use this, I will give everything as default and click on next and then create the target group. So now that I had created the dummy private as the target group, I will refresh it and select the dummy private target group. That's all we need to do. So we have created an internal load balancer with a security group that allows traffic at port 80 in this particular VPC, and it will point to or forward the traffic to each of these private subnets. And we have associated a dummy target group for listening. That's all for creating an internal load balancer. So of course it will take some time for the state to change from provisioning, but we don't need to wait for that. Let it take its own time. So what we'll be doing from our application, we will be using this particular name to hit this particular load balancer so that it forwards the traffic to the corresponding microservice. Next, we are going to create yet another load balancer. Again, the application load balancer. We are going to give this load balancer name. I actually, let me see, so this is ALB private. So let us give this as ALB public. So application load balancer, this is going to be public facing. And so here instead of internal, we will be using the internet facing. And again, we are going to associate with our custom VPC. So if you remember previously, when we created the internal facing load balancer, we had to choose the public subnets, private subnets. But in this case, because it is internet facing, we have to choose the public subnets. So I will choose both the public subnets that I have already created. And then again, so what exactly is the security group that is going to be associated with? We have already created an external ALB load balancer, which allows traffic at port 80. Then which points to, so let me close this. So which points to the which actually is associated with this particular load balancer. And then again, we are forced to create a dummy target group. So let me create a dummy target group again. And this is going to be dummy public. As again, as I told you, we won't be using this target group. The target group will be created when we create the ECS service. You will come to see that. And then I will keep everything as optional or whatever the default. I will just click next and create the target group. So of course you can see there are two target groups, each for, this is for the private load balancer, and we are yet to associate this public load balancer. So let us refresh it, get that public load balancer. Our job is done. And then the summary, we are creating an internet facing load balancer. We have associated a security group with that load balancer that allows traffic at port 80, and it will be forwarding to that particular traffic to each of these subnets, whatever the application running. In our case, Docker containers running in these subnets. And then let's create the load balancer. We have created two load balancers. So we have created, so the private load balancer is already active. The public load balancer is getting provisioned. So we have effectively, so what are the things that we did in this schedule? We created two security groups, one for the internal load balancer and one for the external load balancer. Then we created two load balancers. One is the private or the internal load balancer and an external load balancer. And for each of these load balancers, we created some dummy target groups for the same. Our job of creating load balancers is done. Again, we will come back and tweak these load balancers a little so that the whole application works correctly. So the next thing that we are going to do, we are going to go to the ECS, create the tasks, and then see how exactly we are going to use these load balancers for communication. In this video, we are going to create the tasks in the ECS cluster. So let me take a new window here. Go to the Elastic Container Service and then start creating some task definitions. So let us create a new task. So I'm not going with the Fargate. I'm going with the EC2. Then click on next. So I will give, so the first thing I'm going to create is the config server whose image is available here. So I will go into that particular image and then so create a task definition. So let me give a name. It is config server. That is the name of the task. I will leave everything blank here. I don't have any specific role for this particular task. Roles are given if they want to make some API calls to the AWS services. I don't have any kind of functionality here. So I will leave the task role as blank. And also the network mode, you can see there are different types of network modes. I mean, YouTube has a lot of videos explaining what are these network drivers. So you can see there is a bridge driver, a host, and an AWS VPC. Bridge is the default driver or the default network available in Docker. as well as that is the case with the host. AWS VPC is a specific network provided by Amazon. Again, that is not our discussion. I will go with the bridge. I mean, if you select default, you can read it here. If you select default, bridge will be the network mode that will be used. So we are going to use bridge network here. Again, I will leave the task execution role because I have created some roles tasks previously. I can see there is already a execution role. If you are giving something new, you can go with the create new role. And then I will leave everything blank here, how much memory and all that anyway will be specified when I create the container. So again, I'm just giving a definition called config server. And then let us add the container. So what exactly, let me give the same name, config server as the name of the container. Again, when we get time, we will go through the CI/CD pipeline. At that time, the container name will come handy. And then what exactly is the image? So I will copy this particular URI of the config server and then just paste it here. And then comes the, of course, it is a, I don't need any authentication for this, so I'm good to go. So there is a hard limit and a soft limit. So I will go with a soft limit. Soft limit means how much minimum amount of memory that should be allocated for the container. There's a hard limit. This is the maximum amount of memory that will be allocated for the container. So for the time being, for this demo experimentation, I will give a soft limit of maybe 300. That will do. And then the port mapping. Because the config server is going to be running in port 8888, and I want to have some dynamic ports to be created. So I will leave the host to port blank and then give the container port as 8888. So what effectively this means that when this container gets deployed, the container port will be 88, will be mapped dynamically or be mapped to a port for a dynamic port. And then of course there is nothing much for me to do here. That's all for the container creation. I leave everything as is and click on the add. That's all for the task creation. And then let me complete and create this particular task. So of course I have created some configuration server tasks before. That's why it is appearing here as the revision as 12. If you are creating this for the first time, it will be 1. And then for any new, so how do we update the container? By clicking on this create new revision. So I have effectively created a config server. So here also you can click on this. Suppose you want to update some environment variables or maybe the image or whatever. So you update an existing task by clicking on this create new revision. Again, that is not the discussion. So we have created the task for the config server. And the next task is going to be the book service. So let us create the book service. Again, easy to going to the next step. I will give book service here as the task definition. I put everything default and I will add the container, and the container name is also going to be a book service, and the image is going to be the book service image. And of course I have tagged it as 1.0 and then I just paste it here. Again, for this, I'm going to give a soft limit of 300. And then here, the book service, if you look at the book service, this book service is running at port 8090. So I will give a 8090 for the container port, but I leave the host port blank, or you can give 0 if you want. Whatever is the case, a dynamic port will be mapped to the container port. So again, I leave everything blank. There is nothing much to do. But in this case, there is one thing. This book service, if you remember, this book service communicates with the configuration server. So what we need to do, I'm going to use spring.config.import as the environment variable. So coming down, you can see there is an environment variables section. So I will give a spring.config.import, and then the value will be, first I will copy it here up to here, copy, paste it as the value here, and then after that I will give HTTP. Then what exactly should be the value? That means we are trying to hit the config server. So we will go to the LB. So that particular, we are going to hit the config server using this particular DNS name. And of course, what exactly is the DNS name? This is the DNS name at port 80. So I will copy this and then go back and paste it here. So what exactly we did, if you remember, we created a security group for the internal load balancer that allows traffic port 80 from the VPC. So what effectively we are trying to do here, the book service needs to communicate with the configuration server, and this internal load balancer, the internal load balancer, of course, we need to tweak it a little. This load balancer will communicate with that particular, because of the target group. Again, we will be not be using this. We will come to see those later. So using this particular internal load balancer, we are pointing to the internal load balancer telling, of course, I'm going to send traffic to your port 80. Please forward it to the container port of the config server. That's all we need to do. There is nothing much there. So let me double check. There is no other configuration required. No other configuration required. So we are good to go. So this is the only environment variable, spring.config.import, because when I created the application internally, it was using localhost. I'm effectively overriding the spring.config.import as an environment variable inside the container. So instead of this localhost 8888, it will be using the HTTP that load balances a DNS name. That's all we need to do. Nothing much. Click on the add button. Everything I leave as blank. So that's all there is to it. And then go ahead and then create that particular task. Again, I have created some book service before. That's why the book service is coming like this. So two services tasks has been created. The last task we are going to create is the API gateway. So let us give an API gateway as the name of the tasks. I keep everything as a default here. I will go and add the container, give the container name as API gateway, and then for the image, I will go back to the repository, the API gateway, click on the image and copy that particular URI and then paste it here. That's all. Again, I'm going to give a soft limit. API gateway can take a lot of hits maybe, so I will give a little bit more space, at least for startup. The API gateway is going to work at 8080, I suppose. So I will give the 8080 port here as the container port. Again, it is a dynamic mapping. So again, if you look at the API gateway also at the application.yaml, you can see it also points to the configuration server. So we need to give one environment variable spring.config.import. So coming down, one more environment variable here, spring.config.import, and then the value, the initial value, I will copy up to HTTP, paste as the value here, and then of course we will be definitely using the internal load balancer DNS name. So let me copy this, go here and provide the name. So what effectively means, when this particular API application boots up, it will try to communicate with the config server. The config server is located through this particular internal load balancer. Okay, that's all. But there is one more key here. So if you look at the discovery, you can see there is a booking service I have provided. So here I'm going to give one more environment variable here called booking service. And this also is going to be the same. So let me see how I am actually using this booking service in the API gateway. So let me look at the root configuration, HTTP. So I only need to give the name of the DNS. So let me go back, copy the particular DNS. So this is a little bit different. So this HTTP booking service. So if you look at discovery booking service or 8090. So what we are going to effectively do here, just paste the value of the DNS, but I'm going to give a different port called 81. It will be obvious to you when the time comes. As I told you, this the private load balancer will use this DNS name. If you look here, there are something known as a listeners. This listener 80 is already being occupied, which we are going to use to forward the traffic to the config server. We are going to add one more listener which will be pointing to the 81 or using the 81 port we haven't added it yet. We will do so very soon once we complete the service and all the stuff. Bear with me till then. So that's why for the booking service communication for the configuration server, we are going to use the port 80. That's why, because 80 is a default port for HTTP, I am not giving the 80 port. But for the booking service, we are going to use an 81 port. So I am giving the 81 port upfront. We will do some tweaking later. So these are the only two environment variables that I want to use in the Docker container. I think everything else is good to go. So let us create the container. That's all I'm going to do here. I will leave everything blank and just start creating the third task. So again, I'm keeping this simple. So 3 microservices, not actually, there's only one microservice called the book service. This is the Spring Cloud config server, and this is the Spring Cloud API gateway whose tasks has been created. The next thing is to create the service. We will do that in the next video. Now it is time to create the cluster. So let me go to the cluster. I'm going to create a cluster here. Again, I'm not going with Fargate. I'm going to use the EC2 Linux plus networking as the option for the cluster. Next, I give a name. So this is a demo. So I will give a demo cluster as the name of the cluster. I will go with the on-demand instance, and obviously I will select the T2 micro. I'm going to have how many? Maybe maximum 4 instances. 4 instances not actually required, but then let us create 4 instances. I will go with the AMI whatever is proposed by Amazon, 30 GB of hard disk. I have already created some key pair, and I will be using that particular key pair if I need to SSH into any of these, which I'm not going to, but in case. And then which is the VPC in which this cluster is going to be created? Obviously, our custom VPC. And then I will select all the subnets, the private subnet as well as the public subnet in this case. Public subnet in this case. And then we'll use the assign public for the public subnet. So in this case, what we would like to know that when I created this particular VPC, which so if you look at the particular VPC, this custom VPC, I made sure that this DNS host names is enabled, as well as the DNS resolution is enabled. So what I just did, I just edited the so you can see edit DNS host names. So make sure that it is in the enabled, as well as in the DNS resolution also. Please make sure it is enabled. That is step one. And also for the subnets, for the public subnets that I have created, in the public subnets, I'm making sure that the IP address. So you can see here, enable auto assign public IP address. This is also being checked for the public subnets. So because I'm giving auto assign public IP addresses, each EC2 instance that I am going to put into these public subnets will get a public IP address. That's all there is to it. So when I'm creating the ECS, use the subnet settings means, of course, the private uh, subnets won't get public IP addresses. Only the public subnets will get the public IPs. So that's one thing. And then there is the security group. So again, one more thing. Let us create one more security group, this time for the ECS cluster. So I'm going to create. So I will give ECS SG, meaning I'm going to create a security group for the ECS clusters. So what exactly this means? When we are creating the ECS cluster, we told you 4 instances will be created. So those EC2 instances, of course, a security group has to associate it with those EC2 instances. So this particular security group is going to be associated with those instances created by the cluster. So again, the security group has to be associated with our VPC. And then what are the inbound rules? Of course, if you want to SSH to those public, you can definitely use SSH. And then another rule. So I'm going to create a custom rule. So in this case, if you remember when we created these tasks, if you go back, yeah, I cannot show this now. If you remember, if you look at the previous video, when we created the task, we specified dynamic port mapping. So what we are going to tell, any port from 32767, from 65535, because the ports, the dynamic ports will be in this particular range. So what I'm telling here is that any communication that is going to come to this particular, from where? From custom means I want to have the 2 security groups. So if you remember, we had 2 security groups, one for the external load balancer, and then another custom rule again for the same thing, from the internal load balancer to not load balancer, from the security group of that particular load balancer. So what we are telling here is that please allow traffic to the EC2 instances. Again, the security group which we are going to be associated with this particular cluster. What exactly this cluster means? 4 EC2 instances will be created, and those EC2 instances should have a security group associated with it. So that security group is what we are actually configuring now. And we are telling that that security group should allow these port, any communication coming to these ports coming from the security group that is associated with the external load balancer, as well as from the internal load balancer, should be allowed to pass through. These are the two rules. Of course, SSH is not required if you don't want to SSH from there, but these 2 configurations are a must. So let us create the security group. So we have created one more security group here with the name ECS SG. As always, let us copy paste the name here too, so that it is easy to find it out. So you can see here, again reiterating, we have created 2 rules, inbound rules. One will allow traffic to any of these ports from the internal load balancer security group, as well as from the external load balancer security group. Okay, when I say external load balancer security group. This is associated with the external load balancer, and one will be associated with the internal load balancer. So whatever traffic coming from those load balancers to which the security groups are associated, please allow traffic from there to come in. And of course, these ports are opened up. And then because we are creating, so here let us use that particular VPC instead of creating a new security group. I'm going to use the ECS SG that we have created just now. That's all for the creation of the cluster. So again, I gave a name to the cluster. I have specified on-demand instances of T2 micro, 4 instances, 4 EC2 instances, and I'm giving a key pair if you want to log into any public EC2 instances. All the 4 subnets I have specified, both private and public, and then I'm specifying please assign IP address wherever applicable. If it is a public subnet, IP address will be available. If it is a private, it won't be assigning any public IP addresses. And then I specified the security group that will allow traffic from the security groups of the public as well as the private load balancers. That's all. Let us go ahead and create it. Of course, it may take some time for the whole provisioning to work, so let us wait. So now the cluster has been created. Let us go ahead and view the cluster. If you look at the ECS instances, of course, it will take some time. If you go and look at the instances that we have created, you can see these are the 4 instances that has been started by the ECS cluster. It may take some time to get the whole thing running. So let us wait for the whole thing running. So now that the EC2 instances are running, let us go back to the ECS and see whether these instances are appearing. So again, this may take some time. So let us wait. So as of now, 2 instances are appearing here. We need 2 more instances to be appearing here. So of course, the status check has to be passed for the ECS instances to be appearing here. And now, of course, we can see these instances are now up and running. But before we actually create the service, there is one more thing that we should do. So our use case is like this. We want both the config server as well as the booking service to be provisioned in private subnets. Only the API gateway. If you remember, we created the load balancers. So this load balancer will look for instances in the private subnets. So because we don't want the config server to be exposed to the outside world, as well as the book service doesn't need to be exposed to the outside world. We only want the API gateway to be exposed to the outside world. So when we create a task, we need to tell when we create the services, we need to tell to which instances or into which subnets these services or the task should be deployed. For that, what we are going to do, I will click and so first I have to check whether which is public or private. So I will go with the first one and see. So you can see there is a private IP. So I think let me look at the ECS instance. Let me close this ECR. It is not required anymore. If you look at the ECS instance, I want to see whether this is private or public. So this is a private subnet. So what I'm going to do here, I'm going to click on that particular instance, go to actions, and click on the view edit attributes. So you can see a lot of attributes has been added to this particular instance. I'm going to add a particular attribute here, and I'm going to give, this is custom attributes. You can give group, and then I will give the name as private, or the value as private here. I will click on the green button and apply that attribute to that particular one instance and close it. So I have done with that. The second, again, I will look at the this instance and see which is the this is public. So I will go here, go to action, edit the tag, and I will add an attribute, the same name, group, and I will give the value as public. Again, the usage of this thing will be obvious. That means we want to allocate these tasks based on these attributes. If the API gateway, once we want the API gateway deployed to a particular instance that has this custom attribute of group with the value of public, all the other things, that means the private means we want to allocate those instances. So let me see if this is public. So this is public. So the third one, let me go to the actions, edit it, and then add an attribute of group as public, and then check it and close. And the last instance, I hope this is also, this is private. So the last instance, we are going to select, edit, and then add the attribute group as private, and then save it and close it. So what we have done here, we have just given some attributes to these based on whether it is located in a private or public subnets. So you can see here, the first is located in the private subnet. The second one is in the public subnet. The third one is in, again, public. And then the fourth one, that means the EC2 instance, is in private. So we have effectively two instances that is running in the public subnets and two instances running in the private subnets. Why exactly we are giving these tags will come obvious when we actually start creating the services. So we will start creating the services in the next video. So in this video, we created the cluster with the 4 T2 micro instances. Once those instances were provisioned, we went into those instances, found out whether this has been deployed in public or private subnets, and then we added an attribute to each of these instances, a custom attribute. Already, the ECS cluster has given some built-in attributes, and then apart from this, we could use any of these attributes. But then I am choosing a custom attribute. We are going to use this attribute. Again, you can edit it if you want. We will be using these attributes. When we provision the services, we are going to tell, please run a task that has this particular custom attribute. So effectively, the book service as well as the config service, we want to be deployed into a private subnet. I mean, the EC2 instances running on a private subnet. But the API gateway, we want that to be deployed into an EC2 instance running in a public subnet. For this, we have given this configuration. So that's the end of this video. We will create the service in the next one. So let us create the service definition for the book service. So let us create. Again, we are going to use the launch type as EC2. And instead of the API gateway, we are going to use book service. Oh, one thing I forgot in between. Let us go back to the load balancer. If you remember, when we created the API gateway task, we gave two environment variables. One environment variable was pointing to the config server. Another environment variable was pointing to the booking service. And if you remember, we use the booking service value as the internal load balancer DNS name with a port of 81. So what we need to do before we actually start configuring the ECS, we need to go back to the private load balancer. So if you remember, already port 80 is being occupied. So any request coming to port 80 will be forwarded to this. So again, let me see. Private listeners. Yeah. So it will be forwarding to the demo config server service. So what we need to do, we need to add one more listener, which is going to be any port will do. So let us add one more listener. So by default, it is giving the next port 81. So let us accept that. And of course, any request coming to the port 81, please forward. For the time being, we are going to use the dummy private, and then let us add. So what we have done here, we have effectively created two listeners, one listener pointing at 80 and another at 81. Any request coming to the 80 will be pointing to the configuration tasks. And for 81, as of now, this is dummy. We will change it to the new task that will be created when we create this particular new service. So let us create the new service for the book service. Again, I'm going to use the name as book service. Let us run two tasks of the book service. And I will keep the minimum percentage as 0. And again, this is going to be the balance spread. I don't think I talked about this. Of course, there are different types of placements. So there are balance spread and bin pack. Bin pack means it will try to accommodate as many containers as possible in a single EC2 instance. In the case of a spread, it will try to spread kind of a round robin algorithm where one container will be put into one EC2 instance, and then the next container will be put into another EC2 instance. So we are actually going with the spread the algorithm for placing the EC2 instances. And one more thing, if you remember, we already talked about where to place this container. We want both the config server and the booking service or the book service to be placed in a private subnet or an EC2 instance which is placed in a private subnet. So how do we do that? We add the constraints. We use the member of course, a distinct instance is also available. We are using the member of. Let me copy the attribute so that I don't have to type it. So again, the expression here is that the attribute is group and the value we are going to give it as private. Again, we have already gone through this. Let us go to the next step. Next step is where we are going to create or use the application load balancer. So again, we are going to use the private load balancer, which is an internal facing load balancer. And then, of course, let us add to the load balancer. So here you can see that 81 port. Previously, we were using 80 for the config server. So here we are using the 81 port. And then here also, we are going to create a new target group. So it will suggest a name. Let us keep that name. So it is ECS demo C book survey, something like that. Again, we are going to use the /* with an evaluation order of 1. Again, we can use load balancers as path-based routing is also possible. I'm just using different listeners for my case. And again, the health endpoint will be actuator health. That will do, not the / health. So that is the configuration of the booking service. Nothing else is required. Let us go to next. No auto scaling is required. Let us go to next and see the review book service. We need 2 instances and the application load balancer. The container port is 80, which will be listening on 81. And that's all. Let us create the service and wait for the service creation to happen. And yes, the service has been created successfully. Let us go and view the service. So 2 instances of booking a service has happened here. Let us go back to the I think we have opened up two. Let us just use one. And then the first thing we need to do, let us go to the target group. So as you can see here, a new target group has been created. Let us go to the target and see, of course, two instances of the book service is up and running and is healthy. So is the config server. So you can see the config server is up and running. The book service is also up and running. So now what we can do, we can actually effectively remove this dummy private from association with the load balancer. So let us go to the load balancer and then let us uh, delete this first and then add the listener, and in this case we are going to forward it to the load balancer for the target group that was created by the containers by the ECS. So let us use that and add it. That's all we need to do. Let us then go back to the target group. And now the use of this dummy private is over. So let us delete that particular target group. Of course, we'll be deleting this dummy public also very soon once the API gateway. So again, I want to recheck whether everything is working. Yes, the book service, two instances are running and they are healthy, meaning any communication going through the internal, the load balancer. If you remember, this particular load balancer, if it is 80, it will be taking this particular target group, the config server, and communicating with the Spring Cloud config server. And if you are going through the 81 of this particular load balancer, it will be using the target group of the book service and communicating with the book service. But again, we are using internal. These two services are running inside private. So there is no way we can actually access those things. If you want to see whether this has been really put into a private subnet, you can click on this particular instance ID. And of course, if you click on it, you can see that, of course, see here, there is no public IP for this particular EC2 instance, meaning this has been put into, and you can see it is 192.168.4.9, which I know personally that this is the IP address that I gave for that private subnet. So that's how we have deployed two services successfully, the config server and the book service. Next, we will talk about how we are going to use the public, that means the external load balancer, not the internal load balancer, the public load balancer, and see how to hit the API gateway. That will take up in the next video. So now that we have created the tasks, the clusters, it is time to create the services corresponding to those tasks. So let us go into the cluster, create the service. So it is going to be an EC2 service. Let us first create the config server service, the latest version, and let us give config service as the name. Let us run two tasks. I will give the minimum percentage as 0 for the time being. And then, of course, in the placement templates, if you remember, we want this config server to be placed in a private. So let us click on the edit. And then in the constraint, you're going to add a constraint. And we are telling that this particular service and the corresponding tasks should be placed in an expression. So how do we find this particular expression? Of course, AWS has extensive coverage of how exactly to place the tasks and all. And of course, you can read this documentation, how exactly the tasks are placed. So you can see here we have given some custom attributes. And so how are we going to use these attributes? I think it is in this document. And nope. So let us look at it once again. AWS query language. Yeah, so you can see subject, operator, and the argument. You can see the subject, there is an operator, and the argument. So there are operators specified here. What are the operators? So here we are keeping it simple and we are going to use an equals operator. So it will be like attribute colon attribute name. So let me copy this. So in the expression attribute and after the colon, the key was group and the value was private. So what it effectively means that when this particular service and the corresponding config server is provisioned to an EC2 instance, we are giving 2 as the instance, so meaning 2 instance of this particular task, and we're telling that please put it into a private subnet or an EC2 instance that has been given an attribute of private. Then that's all for this provisioning stuff. Then next step. So here we are going to use a load balancer. So how does this task is going to be reached by others? So we are going to use a load balancer. So in here you can see that two load balancers. We are going to use the ALB private load balancer. Okay, so automatically I have created previous services. So there is already some services existing. For your case, you can create a new role if you want. And then the containers, you can see here there's a port mapping from 0 to 8888. That means a dynamic port. So let us add to this load balancer. And of course, you can see that of course there is a port 80 that will be listening on that particular load balancer. And here I told you, if you remember previously we had created some security groups, sorry, some target groups. So if you look at this is the VPC. So let us go to EC2. And then if you look at the target groups, I told you we will not be using this dummy private. Instead, when we create the ECS, we will create a new target group. And this is what. So you can see here the ECS demo config server, some target group will be created for this particular load balancer. And of course, it is HTTP. The path pattern is going to be anything / and star. And of course, we are giving an evaluation order with the highest priority of 1. And then we are telling I have already included the actuator here. So I will be using the actuator endpoint and the health endpoint for checking. So what happens here is that this target group, this ECS demo target group will only add those instances that is actually healthy. So what exactly it will do? It will go into that actuator health endpoint, and if it returns 200, okay, those EC2 instances, so those containers will be added to the target group, meaning when a request comes through this particular load balancer, and if some hit happens at the port 80, it will be forwarded to those EC2 instances or those containers that is part of this particular target, and only those containers will be part of the target that are healthy. And this is the actuator health endpoint that we are asking for checking it. So this is as simple as it is, right? There is nothing more. We selected the application load balancer. The load balancer was already created for us. We created these things, and the listener port is going to be 80. And then the target group, here we are going to create a new target group, or the service will create a new target group with whatever the name, and then the path, anything, of course, forwarding to the root path or anything after that particular root path. Then the actuator health. That's all. So we are not going to talk about auto scaling in this video. So let us keep the things simple here. So this is the whole thing. And let us create the service and see whether the service has been created successfully. Yes, the service has been created successfully, and then click on the view services. You can see that two configuration server instances because we said so in the service definition. So how do we identify? So if you look at the target group and then click on refresh, you can see that new target group has been created here. And if we click on it and then look at the targets, you can see these two instances are part of that particular target group. So effectively what we can do, we can actually delete this particular private, but for the time being, I'm not doing that. So let us stay here and see. After some time, it will take a little bit of time. If we are able to, or AWS is able to go through the load balancer and hit those endpoints, and if it returns healthy, you will see that those instances will be returning here. So let us again see whether it is still pending or running. Of course, it has entered the running state, hopefully. And now you can see the ECS demo, see this cluster is healthy, or the two instances, the config server instances is running healthy. So what we can do, we can go to the load balancer, to the private load balancer, and then click on these listeners. So what we can do, we can actually remove this dummy private from here. So what I am going to do, I will select that particular listener, delete it, and then again I add a listener, this time port 80. And so what exactly this means, any communication happening with this port 80 of this load balancer, please forward to the ECS demo target group that was created by the service. So let us add it and then view the listeners. So that's the end point. Now what we can do, we can actually remove this particular target group, which we are not, because you can see here it is not associated with any load balancer as of now. So this is how. And of course, let us go back to the target group and see whether the targets is up and running. Of course, the target is up and running. So two instances are registered with the target group. And so the initial creation of the ECS, these two configurations is working fine. The next thing will be the book service. We will take up in the next video. The last task we need to create is for the API gateway. So let us get along with that. So this is, yeah. So let's go back to the cluster and then create the service for the API gateway. So EC2 and then API gateway, and let us give API gateway as the name of the service itself. Let us run two tasks here again. Keep the minimal health percentage to 0, blue green, and of course here, according to what we discussed earlier, we want this to be a member of attribute. So let me copy and then group. This we want to place it in a it has to be public. That means we want this task to be placed in an EC2 instance that is available in a public subnet. So that's all there is to it. Click on next. And of course, here also we are going to use a load balancer. But of course, in this case, it is not the private, it is a public subnet, public load balancer, which will be internet facing. Then let add to the load balancer. So we already have a listener at port 80. And then here again, we are going to create a new target group. If you remember, we had this particular target group, the dummy public, which is not the one we use, because the ECS is smart enough to recognize what exactly is the target groups. So again, the path is going to be / and star with an evaluation order of 1. And then again, this also has the actuator endpoint. So actuator health endpoint is what is required. That's all there is to it. Click on next step. We are not going to use any auto scaling capabilities here. Next, and then create the service. So hopefully the service creation will happen quickly. Let us wait for the service to complete. Yes, the service has been created successfully. Let us view the service. Of course, two tasks of the API gateway has started. Let us wait for this thing to come to running. Or maybe we can look at the target groups and refresh it. So of course you can see the API gateway is up and running, and let us look at the targets. It has just started, and let us wait for the pending state to come to the running state. Now it is in running state, and you can see those instances are now in healthy. So all the instances, the API gateway, the book service and the config service, everything is being done by the load balancer. So the API gateway is provisioned using the public load balancer, and for the book service and the config service are provisioned using the internal load balancer. Yep. So let us go back to the load balancer. So instead of this dummy public, let us delete this and then add the proper listener pointing at port 80. We are going to forward it to the target group created by the ECS service and then add it and complete the configuration. Now we can go back and remove the target group, which is the dummy public, which is now not associated with any load balancer. So let us delete the dummy and clean up, which is not required. So now that the load balancer, everything is working fine. So just in case, so let me just look at the healthy and healthy. So let us go to the load balancer. Then let us look at the public, copy that particular load balancer, the DNS name. I will open up Postman. So how are we going to hit this? If you look at the API gateway, you will be able to see that there is a root configuration here. That means I will give the DNS name, then the book service that will forward to the book service, and in the book service I will have this book controller. So I will give what I'm going to give again the same thing. So I will give the load balancer. It is a GET request, and this will be going to the API gateway. Book service is the path that I have specified in the root configuration, and then book is the end point of the book service, and I am supposed to get a list of those books. If everything goes well, I will get a list of books. Actually, I got a gateway timed out, so let us see what went wrong. So I think the problem timeout is happening because of some security group. So let me see what exactly is the problem here. Let us go to the load balancer. Oh, I think, okay. So the security group, the internal, does not allow traffic. So that was the problem. So let us go to the security group of this load balancer, and you can see it is only allowing port 80. So what we need to do, just instead of this HTTP, let us go for a custom. So both 80 and 81 should be allowed to go through, hopefully this time. So we are telling that, of course, it was my bad, because this particular load balancer will be expecting hits happening at port 80 as well as 81, because that's how we have configured our API version 4. You can see here in the API gateway, the booking service will be using the internal load balancer DNS, but will be hitting the 81. So hopefully this time, let us send the request. And now we got it. So you can see here, we have using the load balancer, which is the public load balancer. we are hitting the API gateway at booking service because this is the booking service, and then through that particular this API gateway, we will route the traffic to the book service at book, and we get the list of books. So how do we know that the round robin? That means the load balancer is actually load balancing. So what I have done here in the book service, I am creating a list of books. That means I'm actually, during the booting up of the application, I'm using this command line runner. And of course, I'm using an int range of 1 to a 10. 11 will be excluded. So, and I am changing that integer to a new book. So if you look at the book constructor, you can see I am using a faker. So faker will generate random data. So one instance will have some list of books, so some ID. So if I again give a hit, let me see if I get a different one. No, I'm getting the yes. This time. So see here, after maybe 4 or 5 hits, the load balancer was kind enough to or change to a different DC2 instance. And you can see, so let me just go on. And now, of course, you can see the load balancer is doing its job. Let me give a hit once again. Again, now this time, so again get away hit. So now, of course, after 4 or 5 hits, the load balancer is taking its job. So it is actually hitting two EC2 instances from, two containers from two different EC2 instances. So the load balancer is now taking actually doing a good job. So you can see here, the EC2, the load balancer is actually load balancing the API gateway because we told through the cluster definition that we want 2 instances. You can see 6 instances are now running. 2 instances of the config server, 2 instances of the book service, and 2 instances of the gateway. So this was our discussion on how to use load balancing. So effectively, what we did, we just created 2 load balancers, one for getting from the internet, and one private or internal load balancer that will be load balancing against different microservices. So I hope you got a catch of what you should do. If there are multiple services, you just need to add one more listener and give the configuration accordingly. That's all there is to it. Hope the series of videos will be helpful to you. See you then.